So this project that I'm going to talk about is actually a parallel research activity that we had under the same funding from New York State Ag and Markets, Agriculture and Markets Department that Jason spoke about the other work that we had. So these were really two separate research efforts within that. And really, I want to kind of say that the emphasis or the impetus maybe for doing this work was because there wasn't good data out there really on what emissions were from manure systems. And we felt, especially in our region, there were also a lot of questions about from the state. I'm kind of speaking from the state level, right? About greenhouse gas emissions from biogas capture systems, which are your anaerobic digesters. And we have cover and flare, cap and flare. We have both of these in New York State. Really, they're trying to obviously reach their climate goals, which have been set since 2019, and working through implementation planning for that. So understanding what these systems are really doing is a big part of how we can improve measurement and also accounting and inventorying in the state. So one of the questions with biogas capture systems, some people call them biogas control systems. I think that's what the carbon market tools use. But these are obviously designed to fully capture biogas from manure, right? And from organics, really. So the idea is that we don't have losses, or we want to minimize loss. And there's always a question from folks, well, we think these, could have leaks and maybe do, but we can't see them easily. We can't really measure them that easily. So how do we know that they're performing? And so that's really what we were trying to tackle. And it's challenging, right? But the first step is maybe to find the leaks. And so really we've identified a tool that is used widely in oil and gas, in the oil and gas sector, which is an optical gas imaging camera. And we did find through really kind of evaluating it first as a demo, so before purchasing, that it was good at finding methods from these systems. We looked both at covered manure storages, like I showed you. So just to clarify, these are, have an impermeable cover, lagoon cover, same material over a manure storage, and they are usually with a flare, because in our region, I mean, these are not heated, right? Like a digester vessel here is. And so these are very different in how they behave than these. So it is important to look at both. So the camera was able to find losses easily at each of these systems when we demoed it. And I guess I want to point out too that there's two different models of the camera, and we chose the less expensive one. And one of the reasons we were able to do that, because we did demo both of them to make sure, was because we can be on farm. So we're not scanning from a great distance away. We're not standing at a road and trying to peek in on methane leaks. We have good relationships with the farms. We say, hey, will you participate in this study? Because we really want to, really quantify and understand what losses might be happening, because everyone wants to know, are these actually a good thing? Or, and so they agreed. They said, yeah, come on farm. So because of that, we can be within a shorter, we can use a less sensitive optical gas imaging camera. So for once each quarter for a year, we have scanned with the camera and done a kind of assessment of 12 different biogas capture systems. So the AD systems, we had 6, you see there, and cover and flare, we had 6 as well. Cover and flare, you can have on digestate, right? So after you have a digester, your effluent goes to storage. Most of them are uncovered or whatever, but we do have farms, actually multiple now, that have a cover and flare over their digestate. And all of the farms separate out solids before they go under those covers, because that's really the best practice. So keep in mind, they already have volatile solids that have been removed in the separated solids as well. And then most of these systems were old. I will say I have some newer ones that I have data from, but just interestingly, I ended up with agreement first from farms that have older digesters. So really, these were all from like 2010. There were a couple, there was one that's 2014, one was 2009. Okay, so they're old, but then they had new RNG, or some of them did. So we did have some with CHP electricity gen, and so, and then cover and flares, we had like half and half. So some were older and then some were newer. And the old ones did have a wide range, so I'm not going to put all the years. But okay, so it turns out cows really like this camera, which I couldn't spend a lot of my time looking at the cow because that wasn't what I was supposed to do. But I can see methane from the cow and I can actually see it pretty well. So we should probably do more with that. But anyway, they were like, why do you care about the manure? So methane, so how does the camera work? Methane and other gases have, have absorption in the infrared spectrum. So this is showing methane's absorption behavior. And so wavelength for methane is actually absorbed at this short wavelength of about 3.5 micrometers. And then also at 7.5 micrometers, I believe. And so there's two different cameras, or at least when we were looking, I know they have like some more, but predominantly these are the ones. So this is what oil and gas like is using to actually meet their EPA requirements. Okay, expensive. This is less, about half. And this proved to be fine for what we needed to do. Uncooled, less maintenance, cooled, more maintenance. Okay, so here's the other thing. We need to, obviously these are qualitative. I will show you they're not, we can't quantify what we're seeing. I know there's some software out there that says it can do that. I think it needs improvement, especially for our applications. So oil and gas might be more predictable. These are very variable. And so long story short, you're seeing images, but you're seeing large versus small. The camera also has a mode of normal and then high sensitivity. High sensitivity really strips out a lot of background absorption wavelengths. I had some notes on here. Radiation, I should say. So it shows you even better what a small leak looks like. And I know this camera can see all leaks because I've seen a 1/4-inch hole in a cover leaking. So it wasn't easy, but I saw it in the high sensitivity mode. So we have a protocol we developed for both ADs and cover and flares. So they're different, similar things, but different. And we kind of improved this over the project. So we started with something and then we got better at what we knew we needed to record. So some of the site conditions, definitely want to talk to the people. Is this thing running correctly today? Because maybe don't go that day, or actually just know that and then understand what that means, right? So then I didn't really say, but the camera can only see point source methane. So it has to have enough concentration, right? That's what that means. So I can't see methane from an open, uncovered storage. It's too dispersed. It's not concentrated in a stream. So it can see, these point sources, we say, obviously, so like a leak or a vent. And for digesters, we have a lot of constant, what I would call constant point sources, because they're running very, at least the vessel type, right? Very steady, usually. Biogas is flowing all the time. If it's in use, you're gonna see if there's a leak in X, Y, or Z. And so anyway, there's these different parts that we would look at. Then there's also temporary or time variant point sources to consider. So you might have, I guess I'm showing you the covered storages now. So those are really what are variable, because a covered storage isn't heated. So sometimes there's methane in a great amount, sometimes there's much less. If there is a leak in the cover, you would generally, if it's winter and it's very cold, it might be very hard, or almost like you wouldn't see that, right? So it's much more challenging and also just intermittent, I guess. And so that's just something to know. Pressure relief valve definitely could be, emitting at any point in time. It's like a safety feature, and the flare. So I will also say that it's important to get training for this, so there's a 3-day training the company provided, and that was really, really important to really know what you're doing. I will show you now what it looks like to see a leak. So this is a digester, and this is a little port. There's the high sensitivity mode. It looks like crap, but you can see the methane really easily. So this was a leak in this little port that they were sort of using, which was not really as designed, to dose something into their digester every once in a while when they had a foaming event. They were actually using food waste. And so we showed the farmer this. There was an attempt to measure, which is challenging, okay? But for this, we could easily kind of cover that up, right? And so we did, and we measured with a few different series of kind of sizes of like capture bag, and then the flow rate, how long it took to fill them. And so it wasn't perfect, but we did come up with a leak flow rate that was equivalent to 2% of the production of this digester's gas. Okay, so a lot of times when people say the leak rate, they use it in percent of production. But that was if it occurred year round. And actually, it was fixed. So the farmer saw this. I actually don't know how long that was going on, but I know he said that he thought the seals were failing from what he first had. He came up with a much better way to fix it, which it has like a 2-stage, I think, clamping or valve process thing. And sorry, I should explain that better, but he fixed it, and now I've been back several times and it never leaks. So find it and fix it, right? And then here's a covered storage. And this is actually the pressure relief pipe. And interestingly, this day, it was warm, it was summer. See the flare? The flare was running, but it was still leaking. Or it was venting, I should say, right? It's not a leak, but like, why is this happening? So, because that's the pressure relief. Okay, the flare is doing what it's supposed to do, but somehow it's the pressure, right? So this does have, happen in the covered storages, I would say, because it's so variable. You have all your gas like in the summer, and it's designed maybe not for that because people didn't even know what it would do. So there's been a lot of learning we're trying to do on the actual gas production from these because of our variable temperature, right, over the year. It makes it very challenging. So, but now you see, and the farmer was able to fix this too. So the way that the pressure relief worked was this is a fairly old system. It had like this, I never know how to explain it, but some sort of way that they could fill, I'm not going to even go there, but he fixed it. He did say the cover blew up in the air by like 4 feet when he did. And then, so hopefully there wasn't a cover leak because then it would have just come out there. But anyway, what the heck? I'm sorry, this is very bad. There we go. Okay, so we had to characterize what we were seeing on the camera. So qualitative data to quantitative as much as possible. So one thing we wanted to do is differentiate a leak from a vent. So really this to us meant a leak would be unintended and during normal operation usually. A vent would be required, so really a safety feature or intended. And then in the event, usually in the event of a system disturbance, but it could be during normal operation like the cover and flare. It really was normal, but something needed to be tweaked to make it work better. And this is a flare. I just want to comment, you can look at flares with the camera, but they teach this in the class. Incomplete combustion, you can assess that. Basically, if it's like a poor performing combustion, but it's hard, it's kind of hard. It basically is if it has a really long tail of cloud, because it's going to show something anyway for the thermal imaging that it kind of has built in. But there's a way to do that too, so. And then really like size, I mentioned already, normal high sensitivity mode. So if we could only see it in high sensitivity mode, we would note that. That means it's small. Of course, where you're standing and all that matters, but we did the best we could. Frequency, so continuous, intermittent, did it get repaired? Definitely noted when you could see other things. So like maybe you don't need a fancy camera because guess what? There's odor every time there's a leak in the cover. You walk by a pinhole and you can smell it. That's not digested manure, so it's very odorous. And seeing heat flow. So I think that PRV, we could see the heat. Okay, so just this is a cover gas pipe collection, had like a busted just way it was connected there, and that was leaking, and the flare was going. So see, that's the thing. You might see the flare, and you're like, oh, it's great, but there's also gas leaking from holes. Here's another, this is an older cover. It had been repaired, but that had split again. So anyway, just finding those. And then the farm can go and like patch it all up. So here's what we ended up finding. So AD to energy systems, and I'm only showing you 8. So 4 AD systems and then 4 cover and flares because the last set is still being processed. So I don't have it today. But these were 4 that we visited for the full year. And this is showing you the number, just quantity of unique leaks and unique vents. Okay, so leaks is in blue and vents is in orange. Okay, and so, fairly low. These mean they were, independent ones, not the same, from the same place. And then we looked at the cover and flares, 4, and we did have, so leaks versus vents. So what I would say from this is that predominantly here, we actually saw venting happening, right? We caught it venting for whatever reason. And in the cover and flares, we definitely saw more leaking, not venting. This one obviously was high. That had several issues, was older, but also they just hadn't been looking for losses at all. Some of the farms are really good at going around and smelling and patching it up. But this one, they didn't really have a need to care. I mean, no one's even getting value carbon-wise really from these yet in our state. So it's just not a priority. And the other thing quickly is total number of losses and then also relative size. So blue is larger and then orange is smaller. And this is like total number means each visit, I would just add up everything I saw. So even if it was the same leak, that means they didn't repair it, right? Because I always would tell the farm exactly what I found. And so this would indicate the ability to kind of quickly remedy the situation or not, maybe depending on what it is. So definitely some challenges with the cover and flares, I think, with like being able to go and repair them, repair those leaks in the cover. And then size-wise, I don't know, not really much to say there. Had a little bit of larger, a little bit of smaller for each one. So I think I have to wrap up. I guess what I have at the end of this, and I'm happy to kind of talk with people because there's kind of a lot to this, right? This is what I would show you as a cover and flares methane from what actually this is measured, I'm sorry. So this is methane as flowing through the meter that it had. And then the flare being lit or not was a temperature sensor. And so for this farm, this example, you can see that it was not lit in the winter. And then it was, so it burned the gas. And then it wasn't again. And again, the winter, because they're not able to light. Like it's very hard to light it when it's a low flow. So then we really have this leaking that happens through the flare most of the time. So just wanted to kind of point out that when you're looking at like the ability of the flare or the effectiveness of the flare, it's both the combustion efficiency, but then the actual uptime. When is it burning, right? And that's going to be different based on everything. Because whether or not the farm has it on, it's working right, et cetera, et cetera. So, so that kind of goes into it. And then this is just data that shows, or this is what is assumed for leakage from a covered lagoon digester, okay, versus an enclosed vessel digester, because this is used in like CAR, Climate Action Reserve, and CARB to do the quantification. So they see that impermeable cover would really have more leaks, collection efficiency about 5% loss, and the enclosed vessel is usually better at about 2% loss. Remember the 2% I found at the digester? That's what that basically means, but so I think it's probably a decent number. Again, really hard to measure a lot of this. So we're trying to just like get a handle on what's what's being assumed and then how does it relate to reality. And then I'm going to skip over this, but I think it's important for people to know that like anaerobic lagoons or covered storages, I mean, they do not produce energy above really that 40th parallel, and that's been known for some time. So we have to be clear about what we're actually saying is a digester or not and what it's capable of and how it behaves. And I will just, that's Denmark data. So how much is too much methane leakage or venting? Turns out quite a bit. So this is our manure storage if we didn't have any treatment. So it's raw manure, long-term uncovered storage from the modeling, okay? And this is actually lower than an anaerobic lagoon. Anaerobic lagoon would be 3 times almost that. Then we have cover and flare. This is our leaking. So we've got about a significant amount from the flare part, and then some from the actual cover. So this is kind of that 5% loss, and then the flare efficiency. And then this is a digester, so similar. These are kind of the standard assumptions used. I do also have here CO2 avoided from the energy. Okay, that's what that is. So then what if we had 15% leaks instead of 3, which is often like what digester people say? Well, then we still would be better than this, right? Especially with the offset. And would you notice this much of a loss? Yes, you would, right? If you're getting money from your energy. So I think it's important to keep in context that I think people will recognize there's substantial loss and that actually we still have improvement. So with that, there are some weird looking